Hello, welcome to this session of geometry. I'm your host Tanvi Banerjee, and today we shall talk about lines, angles and polygons. Before we start, let's refresh our minds. Let's remember the basic vocab words. What's a square? What's a rectangle? And what's a rotation? What's a square? Well, it's a parallelogram and a polygon that has four sides and has all 90-degree angles. What's a rectangle? It also has four sides, is a parallelogram, has all 90-degree angles, but is irregular. And finally, a rotation. It means turning around a center. The distance from the center to any point on the shape stays the same. Now let's proceed further and delve deeper into the slideshow. Let's start with the subject of lines. So here we can see that we can have a transversal line, quadrants, and parallel lines. A transversal line is a line that crosses two other parallel lines. Quadrants aren't exactly lines, but they are the four sections into which the coordinate plane is divided by the x and the y axis. Parallel lines are lines that never meet no matter how far they extend. Now we shall begin our discussion on polygons. A closed figure formed by line segments with its sides not crossing and straight is a polygon. Any shape that does not have these properties is a non-polygon. Can you see the colorful pictures below? They are all examples of polygons. Let's look at the shape in column A and decide whether it's a polygon or not. Take a second to decide. Well, now that we have thought about this, let's get on with the answers. Number 1 is not a polygon as this shape has a curve. Number 2 though is because it is closed, has straight lines and no curves. Number 3 again isn't because it is not a closed figure. Since we now know what a polygon is, let's see the comparison between regular and irregular polygons. So what is the dividing line? If all angles are equal and all sides are equal, then it is regular. Otherwise, it is irregular. The table below shows you the comparison between an irregular and a regular shape. For example, take a look at the example of a triangle. You can see when it is a regular shape, the sides and angles are equal. Whereas when it is an irregular shape, the sides are all different lengths, making the angles different from each other too. Let's see some examples of irregular and regular polygons now. In one column, the shapes are given. Can you determine which of them are regular and which of them are irregular? Now that you have had time to think about it, let's look at the answers. Number 1 is a regular polygon because its sides and angles are equal. Number 2 is an irregular polygon because its sides and angles are unequal. Number 3 again is regular. To further categorize polygons, we can divide them into convex and concave polygon groups. A convex polygon is a polygon with no lines pointing inwards or inside the shape. A concave polygon is a shape with lines caving into it. For example, we could take a pentagon as a convex polygon while we took a star as a concave polygon. Here are some examples of concave and convex polygons. Can you spot which ones are convex and which ones are concave? So now let's proceed with the answers. Number 1 and number 3 are both convex because all their lines are pointing out, while number 2 is concave because 2 of its lines are caving into the shape. The tables below splits the polygons into groups based on their number of sides and their angle sums and their interior angle measures. We shall now switch gears to angles. The most common angles are obtuse, acute, and right angles. Obtuse angles are angles with a degree measure greater than 90 degrees, while acute angles are angles with a degree measure less than 90 degrees, and right angles are a perfect 90-degree angle. Although we have never really gone into the depths of angles, and today we shall explore more about complementary, supplementary, adjacent, and vertical angles. So, two angles are complementary when they add to 90 degrees. In other words, complementary angles are two angles that add to 90 degrees. Two angles that add to 180 degrees are called supplementary angles. Two sides are adjacent if they share a common side and a common vertex. And vertical angles are angles that share a common vertex. We have demonstrated examples with pictures for a deeper understanding. Here are some more examples of complementary angles, supplementary angles, adjacent angles, and vertical angles. Now let's take a peek at what are exterior and interior angles. An exterior angle is the angle between any side of a shape and a line extended from the next. Interior angle is the angle inside the shape. Look below for more examples as they demonstrate how and what an exterior and interior angle is in form of a diagram. Let us take a look at the formula for the interior angles. The formula for the sum of the interior angles of a polygon is n minus 2 in parentheses times 180 degrees, while the formula for each interior angle of a regular polygon is n minus 2 in parentheses times 180 degrees divided by n. In this case, n stands for the number of sides. Now I would like to ask you a question. What is the value of each interior angle of an octagon, and what are the sum of all the interior angles? The answer is each interior angle of an octagon is 8 times 2 in parentheses times 180 divided by 8, which would equal 135 degrees. And the sum of all the interior angles of an octagon is 8 times 2 in parentheses times 180 degrees, and that would equal 1080 degrees. Now for the formula of exterior angles. The formula for each exterior angle of a regular polygon would equal 360 degrees divided by n, and in this case n would stand for the number of sides. Now we should remember that the sum of exterior angles of a polygon is 360 degrees. Ready for another question? What is the value of each exterior angle of a pentagon, and what are the sum of all the exterior angles? Each exterior angle of a pentagon is 360 degrees divided by 5, which would equal 72 degrees. And sum of all the exterior angles of a pentagon is 360 degrees. Here is a fun diagram before we proceed on how to measure angles. Now that we have talked about angles, exactly how do we measure these angles? The most common tool is a protractor. To use a protractor, line up the small hole in the middle of the protractor to the vertex. Then extend the ray going from the top of the vertex to the point where it touches a degree point. It's pretty simple and useful, and it gives you the exact measure of an angle. You can also use two other methods to measure an angle. One is an angle ruler, which works quite similar with the protractor, and the other is our estimation skills. I can give you a random example that is not shown below. For example, if you see a line going through the middle of a 90-degree angle, you would estimate that it's 45 degrees. For something extra, let's go on to symmetry. There's two kinds of symmetry, reflection and rotation. Reflection symmetry is symmetry with respect to reflection, almost like a mirror image of a shape connected to it, while rotational symmetry is a shape that looks the same after a rotation. Have a look at the examples. Now finally, something fun! Do you know that you can do something creative with this topic? It's called tessellations. A tessellation is a patterned tiling on a plane using one or more geometric shapes called tiles with no overlaps and no gaps. Did you know that I recently did a tessellation? It's quite fun. You should try it too. Before I end, I would like to take my time to say thanks to the following websites: www.helpingwithmath.com, www.mathisfun.com, www.schoolmart.com, www.educators.com, Google Images, Wikipedia, and many other websites that I may have missed mentioning here. And last but not least, thanks to teachers and parents for supporting and educating me on these facts. So this is the end, folks. Hope this was helpful, enjoyable, and time well spent for you. This is the end, folks. Thank you for your attention. Hope you liked the session.